Hi everybody, this is the video for solving equations that are in vertex form. So again, vertex form was topic 1 where you can clearly see what the transformations are. Now we're going to solve them when we set them equal to 0. This is how we find the x-intercepts of any equation that's in vertex form. So before, we didn't know how to actually find the values of the x-intercepts. This is a way that we can find them. Another name for them is finding the roots or finding the zeros. Again, 3 different names for the same thing, so just be aware that I can use either of those 3 words, x-intercepts, roots, or zeros. So what we've been used to seeing is things that are in standard form, which is ax squared plus bx plus c. When we set that equal to 0, we can solve by factoring or the quadratic formula to solve them for the x values, the roots, or the zeros. So what we're going to do is learn how to solve equations that are in vertex form, because we can't factor those and we can't use that with the quadratic formula unless we FOILed out the binomial and did all of that work, but this way is much quicker. Right, so that first example, you can just glance up at the steps. It's the same problem that's on the first slide. The first thing we need to do is isolate what's being squared. So x minus 4 is what's being squared, so the 9 has got to go. Use the opposite operation, so we're going to add 9 to both sides. So we're left with x minus 4 squared is equal to 9. Now that we've isolated what's being squared, we're going to take the square root of both sides. So we get just a x minus 4, because the square root cancels out the squared. And the square root of 9 is 3, but we have to remember, if we are not already given that square root, it could be positive or negative 3, because 3 squared is 9, and also negative 3 squared is 9. So then we just need to get x by itself, so add 4 to both sides, giving us x equals positive 4 plus or minus 3. So because 3 is a number we can definitely add and subtract, we're going to find the actual value. So this is really 4 plus 3. And 4 minus 3. So we treat it as a plus first, then treat it as a minus, and we can get the 2 solutions. 4 plus 3 is 7, 4 minus 3 is 1. Right? Let's look at our next example. So again, isolate what's being squared. That 2 that's on the outside of the parentheses is not being squared. Since it's being multiplied, we're going to get rid of it by dividing both sides by 2. Next, we can take the square root of both sides, again, not forgetting the positive and negative version, and the square root of 49 is 7. Isolate x by subtracting 2 from both sides. And again, we've got plus or minus 7, so we can actually do that math. So we've got negative 2 plus 7 and negative 2 minus 7, giving us solutions of positive 5 and negative 9. All right, next example, we need to isolate what's being squared. So there's 2 things that have to move. So we do it just like we would an equation. We work backwards through the order of operations. We have to start with the minus 4, so we're going to add 4 to both sides first. Then we're going to divide both sides by negative 2 because we still haven't isolated what's being squared. We end up with x plus 2 squared is equal to 16. Now we can take the square root of both sides. Again, square root of 16 is a nice number, 4. Don't forget plus or minus. Isolate the x and split it up because we can actually figure out what those values are. Negative 2 plus 4 is 2, and negative 2 minus 4 is negative 6. Now we're going to get into a little more difficult ones. So if we look at example number 3, again, start always by isolating what's being squared, so we're going to need to add 6 to both sides. When we take the square root of both sides, we don't get a nice perfect square. However, we know how to simplify the square root of 18. We are going to split it up into the biggest perfect square and the other factor. That's going to be 9 and 2. Take the square root of 9, which is 3, and we're going to rewrite it as plus or minus 3 root 2. Subtract 1 over to get x by itself, and we can just leave our solution like this. We don't know what negative 1 plus 3 root 2 is, so we can just leave it in plus or minus form. If you want to write it out, negative 1 plus 3 root 2 and negative 1 minus 3 root 2, that's totally fine. I'll take either way. All right, look at number 4. Again, we need to isolate what's being squared. That 2 is being multiplied, so to undo it, we need to divide by 2. Giving us x plus 2 squared is equal to negative 4. When we take the square root of both sides, it's kind of like number 3, where we are given something that we do already know how to take the square root of. There's a minus sign, so we're going to pull out an I. So we'll split it up into 4 and negative 1, so take the square root of 4 is 2, square root of negative 1 is I, so we actually get rid of our radical completely. So we'll rewrite it, x plus 2 is equal to plus or minus 2I. The last step is to just get x by itself, so subtract the 2 over, and here's our final answer. Again, just like number 3, we don't have to split it up into two solutions because we don't know what negative 2 plus 2i is, or negative 2 minus 2i, so we can just leave it in plus or minus form. Alright, our last one's number 5. This one's a little tricky because it kind of looks like the 4 is being taken to the second power, but it's really only the x squared that is being taken to the second power. So we have to get rid of the 4 and the negative 5. So again, start backwards through the order of operations. We're going to add 5 to both sides first. Then we have to divide both sides by 4. 4 is not being taken to the second power, so we have to get rid of it before we square root both sides. Now that the x is isolated with the square, we can take the square root of both sides, and plus or minus square root of 3, we can't simplify that. X is already by itself, so we're done. Right, what I would like you to do is numbers 1 through 8 on the next page. I will be looking at this next class. Thank you for listening.